Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of PW English. Students, I welcome you all to your Nexus Batch, and today we are going to start with lecture number 7 based upon the chapter Classification of Elements and Periodic Properties. So students, this is the time where we are going to finish, we are going to wind up with this particular chapter of ours, that is Classification of Elements and the Periodic Properties. So today we are going to cover each and every topic which are left over from this chapter. That means the last segment, that is going to be the chemical properties and the trends regarding that, right? So here we are going to understand regarding valency, regarding oxidation state, regarding the oxides and the anomalous behavior as well. Moreover, we are going to focus upon what is diagonal relationship. So these are small topics, little topics that are left, and we are going to cover this in this particular session of ours. Yes, I hope so. This chapter you have done really very well, and you have remembered the trick for the periodic table. Because this trick is going to help you throughout your 11th, throughout your 12th. So students, do that, and if you feel that that trick is quite tricky, you can create your own trick and you can write in the comment section that other people can also learn it out. Yeah. So now as I'm coming to this session, that means lecture number 7 of our chapter, shall we start with what are the targets we're going to cover? So I've already told you that in this particular session of ours, that means lecture number 7, first of all, we are going to finish all the chemical properties, all the chemical trends, all the chemical properties, that means all the chemical trends, whether it is valency, whether it is oxidation state, whether it is anomalous behavior, or whether if I'll talk about, the oxides, and then we are going to practice some of the previous year questions. So these are the topics that we are going to cover in this particular class of ours. So the very first segment that we are going to start is the chemical trends. But before that, let us meet with your friends barium and calcium with us. Yes. So they are welcoming you again. Hello my shimmering stars. Have you revised yesterday's class? So yes, he says, hi friends, be ready to finish this particular session of ours. Yes, everyone. Okay. So ma'am, what is our first topic? It is periodicity of valence or oxidation state. Basically, it is periodic trends in chemical properties. Now, understand that what exactly is, the valency and what exactly is the oxidation state. First of all, we will understand this, and then we will be reading from the NCERT highlight as well. So, valency, students, is the combining capacity of any element. What is valency, ma'am? Valency is combining capacity of any element. This is what is valency. Yes. What is oxidation state? What is oxidation state, students? Oxidation state, students, is the formal charge that a particular atom carries. So what is oxidation state? Formal charge on any atom is called its oxidation state. Okay, let us understand now with the help of some examples of valency and oxidation state to understand it in depth. Okay, valency is combining capacity of an element. How do you calculate valency? See, valency basically, students, depends upon A, electronic configuration, B, valence electrons. So it basically depends upon these two factors. That means if you have to calculate, let us consider you have to calculate valency. Valency is equal to number, either it is equal to number of valence electrons or it is equal to 8 minus number of valence electrons. So by this way you calculate valency. Either it is equal to number of valence electrons or it is equal to 8 minus number of valence electrons. Now how this occurs? Let us take some few examples. Yes everyone, are you ready for that? I will be reading the lines written over here as well, but first of all I will make you understand each and everything over here. So as I have already told you, with regarding to valency, let us say that if I am talking about your period number second. Now period number second holds which groups over there? It is group number first, group number second, then we have group number 13th, group number 14th, group number 15th, group number 16th, group number 17th, and then we have group number 18th. Yes everyone. So these are the groups that are present in period number second. Now understand, if I have to write the general electronic configuration, if I have to write the general electronic configuration, then how you are going to write? For group 1 it is NS1, for group 2 it is NS2, for group 13th, what it is exactly students? What it is exactly? Let us take a general example, then you can easily write. For example, we have boron. Boron basically is atomic number is 5, 1 is 2, 2 is 2, 2p 1. That means it is NS2 NP1. What it will be? NS2 NP2. What it will be? NS2 NP3. What it will be? NS2 NP4. What it will be? NS2 NP5. And what it will be? NS2 NP6. So this is the general electronic configuration that I am talking over here. Now what is the role of valency in this? I already told you, valency depends upon the electronic configuration as well as valency depends upon the valence electrons. How you are going to calculate? Number of valence electrons or 8 minus number of valence electrons. So see students, what happens over here? From group number first to, that means you're observing till group number 15th basically. See students, what will happen? So not 15, sorry, till group number 14th. Okay, what will happen? Here valency will be equal to number of valence electrons. That means outermost shell electrons. Now if you don't know what is valence electron, till now I know you know what is valence electrons. If not, see, this is nucleus, this is first shell, let us consider second shell, this is third shell. So third shell is the last shell and the last shell is the valence shell. And that shell contains how many electrons? Will be its valence electrons, right? So coming back over here, it is equivalent to number of valence electrons. That means let us consider for group number 1, what will be the valency? It contains 1 electron, so valency is going to be 1. It contains 2 electrons, so the valency is going to be 2. It contains how many electrons? 2 plus 1, 3. So its valency is going to be 3. It contains how many electrons? 2 plus 2, 4. Now see students, here you need to understand that what is valency. Valency is basically number of valence electrons, to 2 plus 2 is 4. Similarly, here also you have to see number of valence electron. Valence electron comes out to be 2 plus 3, 5. But over here from group number 15 to group number 18, what will be the valency? The valency will be equivalent to 8 minus number of valence electrons. Now 8 minus 2 plus 3, 5. So it comes out to be 3. Yes, 3. Then for this case, let us see. 8 minus 2 plus 4, 6, so it comes out to be 2. 8 minus 7, it comes out to be 1. 8 minus 8, it comes out to be 0. Now coming back to my definition. What was my definition? The combining capacity of any element is its valency. Yes, so see over here, if I say in group number 8 combining 18 combining capacity is 0. That means no more will, no more element will combine with it. That means its valency is 0, so nobody is going to combine with it. So this tells you about the combining capacity of certain element. Now you very well know. Now this was in the case of period that I've talked about. This was in the case of period, students. Yes. But let us consider if I am talking about the group. So in group it is very easy. Again you have to see the number of valence electrons. For example, group number 1 holds how many electrons? Group number 1 holds 1 electron. So valency will be 1 in such a way. Quite easy, everybody. Yes, simple. Now coming back to the definition that is written over here. The valence of a representative elements is usually equal to number of electrons in the outermost orbitals. That means the valence electrons. Here even you can write it. That means it is valence electrons or number of electrons in the outermost orbital, or equal to 8 minus the number of outermost electrons. Both the ways you can calculate it, right? Now we will be discussing about the next part, that is the oxidation state. But yes, I am giving you 2 minutes in order to write the things that we have written on the board, because notes making is really very important. Till then, students, I'll drink a glass of water. Please everybody write this down. Yeah. Shall we? So, write this down as well. Even you can write in your NCERT, students, if you want to. Done with this one? Great. Now see, students, it is NCERT highlights. So first of all, we shall do our oxidation state and then we'll read the NCERT highlight. See, oxidation state basically is the formal charge on any atom. Formal charge on any atom is referred to as its oxidation state. Yes, and there are certain rules to calculate oxidation state, which in depth you will understand in the chapter redox reaction though. But yes, let us consider few examples here. For example, I have OF2 and I have Na2O. Now the thing which I want you all to understand is that this basically oxidation state basically depends upon one factor. It depends upon electronegativity. Now what is electronegativity? We have already studied, ma'am. Ma'am, electronegativity is the tendency to attract shared pair of electron towards itself. So this is what is electronegativity. The tendency to attract shared pair of electron towards itself is electronegativity. And electronegativity basically difference we are going to see, like when there is an electronegativity difference, there are some atoms which gathers a negative charge and other gathers a positive charge. They won't gather completely negative or completely positive. They gather partial positive and partial negative charges. Let us take some examples. So basically, if I'll take this case over here, if I'll take a general case, let us consider we have A and B, and I am saying you students that B is more electronegative than A. Now this is just a general example. This is just a general example that B is more electronegative than A. That means B gathers a partial negative charge, A will gather a partial positive. Why? Because electronegativity is something in which there is a tendency to attract shared pair of electrons. That means the electron that this bond holds will be a bit more closer towards B in comparison to A. Though they both are sharing the electrons, but yes, in the case of this bond, electrons are quite shifted towards B. Okay, in comparison to A. Coming back over here, let us see how we have to calculate. For example, in OF2 case, we know fluorine basically is an halogen, and we have read also that fluorine carries -1 charge only, -1 oxidation state only. But if I'll talk about the other members of the halogen family, if you don't know students, chlorine, bromine, iodine can exhibit -1, +1, +3, +5, +7 oxidation state. But fluorine can only hold -1. Again repeating, chlorine, bromine, iodine can hold -1, +1, +3, +5, +7. But over here, fluorine is an exception, it holds -1 only. So let us consider we have to calculate for oxygen in both the cases, okay? Oxygen now, if you have to calculate, let us assume it as X. Now, the first rule of oxidation state is you have to, add all the formal charges of all the elements, and that sum will be equivalent to 0. If no charge is written on the top, that means it is a neutral molecule. If there is any charge present on that molecule, that means their sum of the formal charges will be equivalent to that number. So it is nothing is written over here. So X plus, now for fluorine we know it is -1 oxidation state. How many fluorine? 2. Overall charge will be equal to 0. Why? Because it is a neutral molecule. So it will be X minus 2 is equal to 0. X here comes out to be how much, ma'am? It comes out to be +2. That means oxygen over here is in +2 oxidation state. Let us see for the case of Na2O. Now see, for let me tell you, Na basically is an alkali metal, and alkali metal, students, holds what's valency? What's not valency? Oxidation state. It holds +1 oxidation state. So now for how many, what is the oxidation state? +1. How many Na? 2. For oxygen, assume it as X. Sum will be equivalent to 0. So 2 plus X is equivalent to 0. X comes out to be -2. So over here oxygen gathers which charge? -2 charge. See now, here it gathers +2 charge, here it gathers -2 charge. That means the charge present on a particular atom, that is oxidation state. Now it is not valency, it is oxidation state. So both of the terms are quite different from each other, and there is very slight difference. Yeah, now I guess you very well know what is oxidation state, what is valency. Let us read the NCERT highlight with regard to this topic as well. So NCERT highlight basically states these statements. The valency is the most characteristic property of the elements and can be understood in terms of their electronic configuration. Already told you, in the terms of electronic configuration, you have to tell me now. The valency of the representative elements is usually, though not necessarily, equal to number of electrons in their outermost orbital, or equal to 8 minus the number of outermost electrons. Clear everyone? So this I have already told you. Moreover, consider the two oxygen containing compounds. Which one and which one, ma'am? OF2 and Na2O. This is OF2 and Na2O. The order of electronegativity of these three elements involving the compound is that fluorine has the highest electronegativity, then oxygen, and then sodium. If fluorine has highest electronegativity than oxygen over here, fluorine will gather negative charge, oxygen will gather positive charge. Then among oxygen and sodium, basically Na, oxygen is more electronegative. Oxygen will gather -2 charge, sodium will gather +1 charge. So by this also you can check. So it depends upon electronegativity. Electronic configuration of both of them, they have written you the reasons that why they are gathering -1, why it is gathering +2. So they have explained you with regard to oxidation state as well. Clear everybody? So you can mark these lines in the NCERT also. Yeah, that means it depends upon what? The difference in the electronegativities. The order is provided you for this. Always remember, fluorine is the most electronegative element, and now you very well know the trend for the electronegativity also. So yes, students, moving on to the next part. Now we have anomalous properties of second period elements, that is a diagonal relationship. Okay, so yes, there are some anomalous properties. Now what are anomalous properties of the second period element? That second period element somewhat shows same property than with third period element diagonally. If I am writing diagonally, they are going to show the same characteristics. Okay, now some elements of certain groups of second period resemble much in properties with the elements of second and third period, are diagonally related in properties, and this relationship is referred to as a diagonal relationship. Which kind of relationship, ma'am? A diagonal kind of relationship. Okay. So now we are going to see what are the properties, what is the reason behind the diagonal relationship. You can open up your NCERT, write in the NCERT, and it will be more easy for you. Yes. Yeah, so now see over here the diagonal relationship. This is your second period elements. This is your third period elements. So just as lithium shows some properties with magnesium, beryllium will exhibit some same properties with aluminium. So they are showing a diagonal relationship that these two holds the same kind of properties, these two holds the same kind of properties. So this is what is diagonal relationship. Let us see. On moving down the group, atoms and ion size increases. This we already know the trend. When we move down the group, number of shells increases. Why this happens, ma'am? Because number of shells increases. That's why we can say that yes, size also increases. The next thing, on moving left to right direction across a period, size will decrease. Why? Because ma'am, nuclear charge increases. Why? Because nuclear charge increases, and if nuclear charge is increasing, outermost electron will come inside and the size will decrease. Next, on moving diagonally, the size remains same. This is what I'm saying, no? They exhibit the same kind of properties, lithium, magnesium, beryllium, aluminium. So diagonally they are going to have the same kind of, you know, behavior. So over here the size remains same. Next, diagonal similarity in electronegativity value. Now these are the reasons, okay? Diagonal similarity in electronegativity values also. Next, beryllium and aluminium also show diagonal relationship, which I have already told you, okay? Now let us see the next part. Beryllium and aluminium also show diagonal relationship. Why? In this case, size are not so close, but the charge per unit area is nearly similar. So we told you there were some reasons where size was responsible, but over here size is not that much close, but yes, charge per unit area is nearly similar. So they also show the diagonal relationship with each other. Now, what are the similarities? What are the similarities? That's why they're exhibiting the diagonal relationship. Let us read it one by one. So in the case of, as I've already told you, here is lithium, here is beryllium, here if I see, always remember students, whensoever I am writing these key points over here, so just put them in box and write in NCERT, because see, all of these which I have written over here, like in circle and box and star, that means these are important key points. So you have to mark all of these in NCERT, right? Now, similarities, let us see. Lithium and magnesium both react directly with nitrogen. Now, I am talking diagonally. Below lithium is sodium, below beryllium is magnesium. Now, I am talking about their properties, lithium and magnesium diagonally. So, lithium and magnesium both reacts directly with nitrogen. They will react with nitrogen. It will form lithium nitride, it will form magnesium nitride. Whereas, other alkali metals of the first group, that means this one, yeah, lithium, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, these all does not form nitride. They do not form nitride, but lithium will form nitride because it shows same similarities with magnesium. They both form nitride. Rest, other members of the group number first, don't form that. So this is the very first similarity, students. The next is fluoride, carbonate and phosphate of lithium and magnesium are insoluble in water. They won't get soluble in water. Whereas these compounds of other alkali metals are soluble. Other alkali metals are soluble, but of not lithium. It is insoluble. Lithium and magnesium both are hard metals, whereas other groups of first A are soft. Rest of them are soft, only they both are hard. So the same diagonal properties. Clear? I guess everybody has written this line so that I can move on to the next slide now. That's great. Now comes LiOH. That means I am now making what? I am here referring to as bases, hydroxides. So lithium hydroxide and magnesium hydroxide both are weak bases, whereas hydroxides of other elements of first A groups are strong base. So this is one more similarity of lithium and magnesium. Next, their melting point and boiling point are very, very high. Last is by thermal disintegration. When you are going to, do the heating process, thermal means in the presence of heat, you are breaking it, you will see they will disintegrate into what? LiO2 and MgO. They both are obtained. So they show the similarity between the diagonal relationship. Clear, guys? Clear, clear, clear. That's great. Now let us read the NCERT highlight also. See, the first element of each group, that is lithium and beryllium, and groups 13, 14, that means boron to fluorine, differs in many respects from the other members of the respective group. For example, lithium, unlike other alkali metals, and beryllium, unlike other alkaline metal, form compound with pronounced covalent character. The other members of these group predominantly form ionic bond. So this is one more characteristic, that they form covalent bond and other members form ionic bond. In fact, the behavior of lithium and beryllium is more similar with the second element of the following group, that is magnesium and aluminium. Yeah, so they will show the diagonal relationship. This sort of similarity is commonly referred to as diagonal relationship in the periodic properties. Clear, everyone? Okay, ma'am. Okay, ma'am. Now, students, comes the last topic of our class, that is going to be the oxides. Let us read about it. See, Now this is from NCERT, you can understand directly because oxides basically are acidic, basic, amphoteric and neutral. Yeah, these are the oxides. So let us see now. Elements of two extreme periods easily combine with oxygen to form oxide. See, when elements of a particular period combines with oxygen, it will form oxide. Yeah. So now the normal oxide formed by the element on extremely left. That means your group number first, second. That is basic in nature. That is Na2O. If Na you know is group number first element, that means alkali metal. If alkali metal is forming its oxide, it is going to be the basic in nature, that is Na2O. Whereas the formed by the element on the extreme right, students, is acidic. That is acidic. That means the P block element over there, that is Cl2O7. Now, oxides of the elements in the center, that means the D block ones, are amphoteric. What are amphoteric? Which shows both the properties of acid also, of base also. That is what is amphoteric. Yeah. Example, Al2O3, As2O3. Or they can be neutral also. For example, CO, NO, N2O. Amphoteric oxide behaves as acidic with bases and with basic with acids, right? Whereas neutral oxides have no acidic or basic properties. Amphoteric is holding both the properties. Neutral is holding no property. Yeah. So this is very easy. The alkali metals are showing, the basic character. The P blocks are showing acidic one. The D blocks are showing the amphoteric ones. Right? Clear, students? That's great. That's great. Now, students, we are going to start with some questions. I would request each and everybody to write it down and mark in NCERT. And I will be writing some of the questions for your practice sake. Just give me a minute. Yeah. First of all, let me give you some homework and then we will practice some questions, okay? Let me give you some homework. Then we are going to practice some questions. First homework question for today is, which of the following orders of ionic radii is correctly represented? A part is H negative, H positive, H. B part is Na positive, F negative, O2 negative. C part is F negative, O2 negative, Na positive. D part is Al plus 3, Mg plus 2, N3 negative. This is the first question as your homework. Now let me tell you, this is a previous year question asked in 2014 examination. Now coming to the next question which I am giving you. This question is basically your 2007 question now. With which of the following electronic configuration an atom has lowest ionization enthalpy? Lowest ionization enthalpy. A is 1s2, 2s2, 2p3. B is 1s2, 2s2, 2p5, 3s1. C is 1s2, 2s2, 2p6. While D is 1s2, 2s2, 2p5. So this is your second homework question and it is asked in 2007 examination. Next. Question number third, this is asked in 2006 examination. Which of the following is most basic oxide? Is most basic oxide? A SCO2, B Al2O3, C Sb2O3, while D Bi2O3. Clear? Clear everyone? Clear everyone? Now, the next question. I'll give you 5 questions, okay? This is the 4th question. 4th question is, correct order of first ionization potential among the following elements that is beryllium, boron, carbon, nitrogen, oxygen is. A option, boron, beryllium, carbon, oxygen and nitrogen. B option is boron, beryllium, carbon, nitrogen and oxygen. C is beryllium, boron, carbon, nitrogen, oxygen, and yeah, D option is beryllium, boron, carbon, oxygen and then nitrogen. Yes, now writing the 5th question for you all. Here comes 5th question. You have to tell me which of the following order is wrong. Which order is wrong? So starting with A option, it is NH3, PH3, ASH3. This is acidic order. B, Li, beryllium, boron, carbon. This is first ionization potential. C, Al2O3, MgO, Na2O, K2O basic. And D option is Li positive, Na positive, K positive, Cs positive. Ionic radii. Ionic radii. Yes, everybody, please write it down. Yes, everyone, please write it down. Clear, everyone? So these 5 questions are your homework, students. Also, my leg is somewhat not well because it has been injured. So I will do the questions, the previous year questions in the next class. Next class we will be holding a bit, lengthy one. Though this is going to be the short section because we had only some few topics left that we have covered in this particular session of ours. The 5 homework questions which I have given you is as a homework of the previous year question papers. One more thing is your homework, students, which I would request each and everybody of you do is question number 6 is solve NCERT back exercise. Complete NCERT back exercise. Complete. Okay. So in the next session, we are going to start with new chapter and we will be taking at least 15 to 20 minutes or more than that for the discussion of all the homework questions of all the session, right? Because I'm not able to, stand for a bit, longer period. So what we are going to do is we're going to practice some more questions in the next section of yours. So I would request, we have completed the chapter now. Now it's your role to do it by your own, revise all the notes. Make, the variation parts that I've given you yesterday also in your homework, create a variation chart, write all the variations on a single sheet of paper and then solve the questions. And then if you have any doubt, you can write in the chat section. Though we are going to discuss each and every homework question in the next lecture. We will be starting with a new chapter. I hope so this chapter was quite easy and you were able to understand it in depth also. So now students, it's time to say bye. We are going to meet in the next class. Till then, keep smiling, keep learning. Thank you so much and have a good day, everybody. Take care of yourself. Thank you.